All right, and welcome to this week's episode of working with Semiotic to make Pokemon dashboards. I should come up with a better title for these live streams, because every time these live streams start, I'm suddenly struck by how I have no idea how to introduce myself to these things. But so this is a Pokemon dashboard that we were working on last week, and I'm going to dive into some of the elements to how to make this into a better dashboard, or to touch on some of the points that come into dashboard design and interactivity when using Semiotic to make dashboards. If you remember from last week, this is a little bit different. It's a little bit different here than how I left it last week. So last week, we built out a dashboard. It had a scatter plot, a brushable scatter plot, and a bar chart for looking at Pokemon height and weight. And that's still fundamentally here. You still have this little brushable mini-map using minimap XY frame. And instead of a bar chart, though, I've replaced that with a violin plot because of some Twitter comment about the bar chart and trying to understand how the distribution of the height on the bar chart, how it was distributed. I think somebody was asking about like what the average height was, the average weight was, and I said, well, you know, you can have the average or you could have a distribution. And so that's what I've got over here, but you'll notice that these distributions don't look like your nice clean violin plots that you typically see. So typically, when you see a violin plot like this, and it's got this kind of pulsing nature to it, that means that you've got your values binned in bins that are that aren't granular enough. So by default, the binning summary functions in Semiotic can be overridden by sending a specific number of bins to the type. So I'm over here in my type bars component. Now this is all in a repo, this Pokemon Semiotic Pokedash repo. I should change the README on it so people understand what it actually is. But I'm going to drop this in the chat. So that's the repo that I'm using. You can go and clone that on your own. In fact, I'm going to change it right now. I'm going to go over to Semiotic Pokedash, and instead of this being a giant React Create App thing, I'm going to say what it actually is, which I should have done in the first place. This is an example dashboard, data visualization dashboard, built with Semiotic, React Create App, and Semiotic. To demonstrate how to use Semiotic to make dashboards. There we go. And maybe at some point I'll update that and I'll put a link to the videos. But anyway, update README. That's what you tune in for, is to see me update a README. So I'm over here in this type bars component. Type bars, now poorly named, drives this violin plot over here. So type bars uses an ordinal frame to create a bar chart. If you didn't see it from last time, it looks something like this. So there's the bar chart that I made last time, except it's not colored right now. But instead we're showing a violin plot. That violin plot is showing the density. If I want to, I could show the density of the points that's driving that violin plot by adding a swarm plot to it. And you can see all these points that are being aggregated into these violin shapes. And so what we want to do is we want to send fewer bins than this so that we see better violins. Actually, the violins are okay when I have no filtering. What happens is when I get some filtering, the violins become very, like I said, overly granular. So what we can do is we can go into the violin plot. And this is fundamentally how all of the different line types and area types, network types, node types, edge types, those kind of things, how you send them more advanced options in Semiotic. So you can send them a string of type equals to one of these built-in strings, one of these built-in sort of data visualization types that Semiotic supports, or you could send an object of type equal to that string, and then it exposes these other values that you could send to it. So I could send only 20 bins. So now you can see that these violin plots are more sort of generic. And then when I zoom in, I still see sort of this, crimping. But that crimping is not so bad. I could change it down to 10. And there isn't a correct answer to this. There are some data-driven answers to this, but there are just better and worse based on what your data set and what you're doing with your data set. And of course, if I do things over here like filter down to only a particular range of heights, right, which is literally what I'm doing with this, when I shrink this, the X, the width of this rectangle in my brush, then of course I'm going to get very sort of particular ranges of height in meters. You can see this. I'm only looking at Pokemon between 1.4 and 2 meters in height. So there's only so much you can do once you start to make your data set really sort of constrained. But by adjusting these bins, it's a useful technique to have the kind of binned data visualization that is most suitable for your data type. And so bins is an option for any of the binnable data visualization types in ordinal frame. What are the binnable data visualization types? Well, it's basically everything except for box plot and contour. So if we look at heat map, you'll see that heat map now has 10 cells. If we go to histogram will have 10 bars, and so on and so forth. So this just literally determines the number of bins in the histogram underneath that ultimately drives the creation of either a histogram or a heat map or a violin plot or a joy plot. So I'm going to go back to violin because I think that works best. You might notice that I've also added this little chart underneath here, which shows Pokemon by their generation and how they change in their attack value. So I thought this was an interesting data visualization thing to expose for this Pokemon dataset, because there are many of your Pokemon can evolve, and this becomes, from what I understand, a more involved process in later versions of Pokemon. And so you have sort of an early version, and it evolves into a later version. And in some cases, here's what's interesting to me, especially as an outside observer, is that in some cases, the next generation might not have as high an attack. It might actually go down in its attack value. Typically it doesn't, and and I think it never does in the third generation. There's one weird Pokemon in here, which is this weird normal type that starts out as something. I can't even remember what it is. And it can evolve into different themes, apparently. I don't think it's in order. Most of them evolve in order, and they stay within the same type. But some of them move between types, and some of them can sort of evolve in the star pattern rather than a linear pattern. Something interesting to explore. And then it is also interesting to see these different Pokemon that end up evolving into something that has a lower attack value. Presumably that's because it has a higher value in some other attribute. And I made this brushable, so I drove that data set to only show the Pokemon the families of Pokemon where those Pokemon are within my brushed region. So I could show you the evolution paths of all of the heavy Pokemon, right? These are all of the Pokemon that weigh a lot. And we can see their height in meters actually has an interesting distribution versus light Pokemon, all these little Pokemon, which is what I always thought. I thought all Pokemon were small. But if we go down to very lightweight Pokemon, we can see how they evolve, right? And I mean, this is fundamentally how a dashboard works. Maybe you're not exploring something quite like Pokemon, but this way I can start to bounce around here and I can look at the distribution, right, of the families or the types. I can look at whatever the distribution is, split by those types. I can look at that distribution, you know, I can compare across the height versus the weight on a scatter plot. I can look at just the height, just one of these numeric values, broken down by type. And I could create some little brushable navigation here and also look at it over time or over some other continuous variable. So I feel like this is a nice little dashboard. It's got a legend, it's got various views into the data, it's interactive. You could imagine the interactivity that you would have if you had a data source that you were going to filter and query, and that'd be driven more by traditional UI elements. I don't feel much need to get into, say, how we integrate material UI interfaces into this to talk to Druid data sources. These are things that we do, that I do in my everyday job, but I feel like that's kind of outside the scope of trying to explain to you how semiotic works and how you might make a dashboard that uses semiotic for its data visualization components. I've got two things that I want to cover finally, and one of them involves installing a D3 nest. So I've got D3 nest over here, or I don't have D3 nest, but I'm going to go and open up D3 collection so we can talk about this a little bit. So D3 nest is a function in D3 collection. I'm going to go install that. D3 collection. And what I'm going to do is I'm going to use nest to nest my Pokemon into a hierarchy. And I'm going to nest them into that hierarchy so that I can visualize the hierarchy of Pokemon. One of the features of this data set that gets obscured in the way that I have visualized it is that some Pokemon have more than one type. So I've been looking at, throughout this whole thing, I've been looking at types of Pokemon. And this gives me some general sense of the population of Pokemon, right? I can see that there's more water Pokemon than poison Pokemon and so on. But I think that what's missing from this view is a visualization that really shows how many Pokemon are in what kind of type. And also, more importantly, you'll notice that a lot of these types that show up in the legend don't show up in the breakdowns because these are subtypes. They only exist as subtypes or secondary types, or I don't know necessarily that they're secondary, but they definitely show up in the type 2 column in the Pokemon data set. So what I need to do is I need to take that Pokemon data set and turn it into a hierarchical data set. So let's go look at the data back in my app. And remember, everything's being done in the app. I'll still base it on the filtered data because I think that it'll be interesting because that filtered data is going to drive that brush. So let's console.log filtered data. See what that looks like. Finally realized, for those of you who were watching last time, I was not sure what was going on with these nans and this rectangle. This has something to do with this brush over here, so I think I'll be able to fix that after this stream. So you'll notice the filter data comes back empty. And what am I doing down here? Well, I'm doing filtered data or pokey data, right? So what I'll do is Be nice if instead of sending an empty array, I was sending back an undefined, so I could just do that. But unfortunately, I'm not. I don't want to get too deep into making this, fixing the code in this. I want to show more of the examples. So instead, I will say nested data equals, I have to import nest from D3 collection. D3 collection. And even someone who wrote the book on D3 still goes and looks at the API, especially since I use nest a lot. And it's one of those things that I'm still not quite sure has changed since version 3 versus version 4. So nest key. So nest has keys, and these keys are going to determine how your Pokemon are nested. And what's interesting here is that I gave all my Pokemon families. So if you look at this, this isn't in the basic data set. They all have a family, and that family just means that that's the name of the first Pokemon to show up in this evolution, right? So Magikarp turns into Gyarados, which sounds like Giardia, and that does not sound like a fun Pokemon to have. But I don't know. And it's an atrocious Pokemon. I just love that. So you'll notice that the classification gives us something we could categorize by. That family gives us something we could categorize by. The types, which is where I was going to start, gives us something to categorize by. So maybe we can come back to this and take a look and see if by categorizing them by classification or family, that'll add to the structure. But for now, what we'll do is we'll pass a couple of keys, and those keys will be to return type 1 and to return type 2, which basically just means that we're going to nest them by their first type and then follow that up by nesting them by their second type. And so in the cases where something doesn't have a second type, which I wish I could find, it seems like now everything does. Anyway, it'll put it into the sort of blank string category. There we go. So this one doesn't have, and so what we'll want to do is we'll want to have or none, right? And then the entries are filtered data dot length is greater than 0 and filtered data or Pokedata. In other words, check the filtered data. If the filtered data is longer than 0, then we're operating off of filtered data. Use filtered data. Otherwise, use the unfiltered data. Like I said, there's cleaner ways to have set that up so that I don't have to do this kind of thing throughout. But this happens, for me, this happens all the time in early phases when you're building out an application. So I'm not terribly concerned by that. So now we've got nested data. And this is what nested data comes back with. Nested data comes back with an array of your top level nest and the values that are in it, which is your second level nest, which looks like I spelled none with a D, which happens. So, particularly high class spelling of none. So this is telling me what kind of subtypes each type has, and then what kind of Pokemon, actual individual Pokemon, exist within that subtype. So here's Ghastly in this ghost/poison type. And that gives me hierarchical data, but what it doesn't give me is hierarchical data in a JSON hierarchical structure that the hierarchical layouts in D3 expect. So that's what I'm going to need. But first, what I want to do is I want to go and build out the component where I'm going to make this. So we'll call this Pokemon hierarchy. Save that. And instead of ordinal frame, we're going to be importing a network frame into this. Probably end up going to be making this quite a bit larger, but we'll see. We'll see how it ends up. Once I get this set up, I'll start to explain where I'm going with all of this. So my expectation is that I'm going to send some kind of data to this. Probably also send one of those, that functionality to color things later on. But this is the data I'm going to send. So save Pokemon hierarchy. Go into app, import Pokemon hierarchy. So I'm just importing the component that I'm going to add to my app, to my render function below. And I have no idea, I've lost track of where everything is. So let's see, I've got one row with a column with a brushable scatter plot. I'll just put it underneath the brushable scatter plot. That seems like a good enough place for it. Pokemon hierarchy. And like I said, this is what I'm sending as data, nested data. Now let's go over to Pokemon hierarchy and console log data. This might be slow for those of you who have already done this, but I kind of wanted to walk through this, even though this is more of a D3 thing than it is a semiotic thing. Hey, why are you not opening? Okay, so it's the same thing, right? I've gotten it down to my Pokemon hierarchy. If you are familiar with D3 hierarchical layouts, you'll know that a hierarchical layout in D3 actually takes an object. So an object has to have a root node that holds all of these objects that were sent back from nested. And what you want it to do is you want it to match the structure. So you want it to have, if things are called keys here, then you want to use key. If these are called values, then you want to use values. So our actual data, and it's sent to edges, because this is an edge list, is going to be this object, key equals root, and values equals data. And the type that we want to send here is going to be a dendrogram. There's a little bit more to it, because what we have to do, by default, the dendrogram layout, just like all the hierarchical layouts in D3 that Semiotic uses under the hood, they expect your data to be formatted in a particular way. They expect your data to be formatted with the hierarchical structure described as using this children key. So instead of values here, it should say children. So this wouldn't work out of the box. And so even though I literally wrote Semiotic, I always have to check my API when it comes to this kind of thing. Over in network frame, I've got some examples of hierarchical charts. We go look at the hierarchical chart. Here we go. That's not what I'm looking for. Let's go see if I'll continue to mumble about it while I look around. And no, okay. So what I'm looking for is I'm looking for like a hierarchy, the way that I designate children. And this is something that I don't like to do because I feel like I should know this off the top of my head. But I'm going to go into the actual code for network frame and go look for this hierarchy. Root node. Here we go. It is called hierarchy children. So hierarchy children, all that means is what's the function that I'm using to designate what my hierarchical children are described as. So if we go into the code here, then I say hierarchy children, D, return D.values. And this is just passed literally to the hierarchy function in D3 once this is built. And let's go see edge style. Need to tell it how to color it. And let's see if we're actually drawing a dendrogram somewhere. Nope, it doesn't look like we are. I wonder what I've forgotten. Let me make sure I've got key, root, values, data, nested data. Oh, I wonder if it's even called a dendrogram. Isn't it called a, let's see. Return, network frame, edges. Oh, how about network type? There we go, much better. Gosh, I was getting a little bit nervous there. So here we go, we've got our network. That's really all there is to it. Getting some warnings because of the keys that are being used. I tell it my node ID accessor equals key. That should take care of that. By default, it's looking for something called ID. Still giving me warnings. I'll look into that later. Good. So we've got this network, but really what I want is I want this to be projected radially, projection radial. Much better. And now I want it to have color. I want to give it some margin because it's overflowing a little bit. And I want it to be colored in the same way that everything else is colored, right? So you get some sense of what the heck is going on here. Node style. Now node style is going to be complicated because I'm going to be passing, remember that because with these hierarchical layouts, this can be difficult. I'm going to be passing these various, whether it's the leaf node, the actual Pokemon object itself, or what it's been rolled up into, it's going to come back with these different values. So let's take a look and see what that would be. It would either be, first of all, I have to send these colors down, right? I have to send type colors. If I go look at type colors, if I remember correctly, this is just a hash. It corresponds to Pokemon types, right? Great. I'm going to send type colors through. As a color property. Go back over here, pull color out when I'm coming in, and I'll do it this way. I'll say if there's d.key, right? If there's a key, then that means that I'm in a, one of these meta nodes, one of these hierarchical parents. And so then in that case, I will just return colors of d.key. But otherwise, if there's not, then that means I'm in a leaf node. I'll return color of d.type1. And I'm still, even though I've told you that I've got type 1s and type 2s, I'm still going to use type 1 so it'll correspond across my dashboard. It'll have the same color across the dashboard as everybody else. And it exploded. Style prop expects a style or something. Oh yeah. That was a mess. What am I doing here? What I want to do is I want to actually send, right? Node style isn't just a function, and then it says, well, what do I do with this color? I have to return an object, and that object has to be a React style object. Much better. That was a little bit silly. So there we go. Now we've got our Pokemon split out by type and subtype. Type 1, type 2, and then the actual individual Pokemon themselves. I kind of feel like type 2 then type 1 might be kind of more interesting. Let's go see. It's an easy enough thing to check out. So to do that, you just say type 2 or type 1. You have to send none to that top one there. So none and the root node are both going to come back black, but otherwise, yeah, I kind of like that more. I'm not sure why, but I kind of like that more. So here's some stylistic things that I like with making hierarchical charts. The root node is implicit, so we can actually get rid of the root node. So if d.key equals root none. Otherwise, that I don't really feel any need to have a root node in there. And now we need to do the same thing with the edge style, right? So edge style is going to have edges that we're going to base our styles on, and edges are going to come back with a structure of d.source and d.target. So instead, we'll base it on the source. We'll have the same rules, and that should take care of everything there. Okay, wait a minute. Edge style. Node style, edge style, D. Oh, right, it's not fill. I don't want fill. I want stroke. And I also don't want to send two different edge styles, right? There we go. Maybe not. Edge style, stroke. That's source.key. Otherwise, d dot, there we go. Source.key. Okay, that makes me happy. Isn't that interesting? So other doesn't get its own. So let's go into color and say none. I don't even know what to give none. It's a beautiful color scheme, and I really wouldn't want to just lose it, but I think I'll just give it black for now. So there we go. Now we have some census of our Pokemon, right? According to what we think are important splits. So you can see these all these Pokemon over here that are I mean, if I wanted to, come to think of it, I could just get rid of none entirely, but maybe that's interesting information. Maybe people don't need to see that. Let's go see. Let's actually do that. Actually, the more I look at it, the more I think that's the right approach. I keep saying I don't want to get too caught up in building this out, right? But source.key equals none, or d.source.key equals none, and then the same thing up here. Can't help but get caught up in doing data visualization when you're trying to demonstrate data visualization. And data visualization isn't just about making things. It's about, you know, making sensible things, things that are thoughtful. So actually, I like that. I like this. I feel like this, you know, big open space here. I could put annotations in it. I could put a title in it. I could put anything in it. So that's not such a problem. And then visually, I think it describes the situation much better, which is that I've got all of these that are of a single type, and then I've got all of these that are of multi-types, and so I can look over here and immediately see that the fighting types have a lot of secondary types, and that the poison types have a lot of secondary types. And to me, that's very interesting. I almost feel like I should pull out the normal types. Like the normal types just mean that they're normal, but I have no idea what that actually means. It could be that normal is a meaningful thing. And now, hopefully, things aren't crazy. Yeah, it's doing some very interesting, not unrendering our edges. That's not what it's supposed to do. Bad edges, bad. I'll go dig into this. I have a feeling that this isn't going to be fixed by just playing with render key. So by the time you see this, this bug will be corrected, and we'll get we'll get good little filtering. You can see that it's filtering the nodes, but not the edges. I wonder why. So the nodes are doing just fine, and it's creating new edges, but the edges are completely just blowing up, and they're not being replaced. I'll take a look. So, but what I wanted to focus on here, though, was you've got a dendrogram. That's great. But what you could do is you could also show this as a tree map, right? You could say tree map. In the case of tree map, I have to tell it, because tree map tracks the values of things. I have to tell it, well, what am I totaling with my areas in my tree map? So I have to tell it something like d dot. I want to say it's attack. It could be weight, right? You could follow the theme and just sum up weight and find out the heaviest Pokemons. I love calling them Pokemons. I do that on purpose. Weight underscore kilogram. Shouldn't give it away, right? I should really own that I'm mispronouncing it. And here's, I forgot that I actually made a radial tree map. Don't hold it against me. It's not my fault. I did make a radial tree map. It is available in case you need radial tree maps. Vertical. Let's see. There we go. And there was a tree map. A tree map, you want some node padding. I think it's node padding. I want to say it's node padding. It might just be padding. If it's not, I'll have to go look it up. Padding. The rule of thumb here is that what it does is it spreads, there we go, it spreads the actual individual keys down to the underlying D3 function. So if you're ever in doubt, if you're familiar with D3 or you're looking over at the D3 API, then what you need to do is just go in and set up a key, and it'll be fine. Just pass as a key to your type. I'm sorry, maybe that wasn't clear. I was checking something else. Except for in some of these, like this hierarchy children and hierarchy sum, because those have to be processed in a different way and passed to a different area. But otherwise, if it's just properties of the underlying layout, then you should be able to just pass it through in the type. And if not, then report it as a bug, because it's supposed to work like that. So hierarchy children and hierarchy sum are slightly different because those have to go into a different part of the sort of data processing chain. But otherwise, yeah. So what we've got here is, if I increase the padding a bit, I'll probably be able to see a little bit more. But it looks like, unfortunately, because of the way tree maps work, I've got this tiny little thing here that's going to go away. So I'm just going to work with what I got. You can see the same hierarchical information, right? I can still see these fighting Pokemon. And I can see the different types that exist underneath them, and so on for all of these other Pokemon types. Here's those poison Pokemon, and you can see the types that exist underneath them, and you can see the weight of them, right? You can see all of these normal rock, normal Pokemon, these rock Pokemon over here, and so on. These are all ground Pokemon, so I guess ground and rock is a subtype. And so even though we don't have very many ground and rock Pokemon, they're very heavy, which is not very surprising. So anyway, there's a tree map for you if you want to do a tree map. What else? We can do a circle pack. I think it's, I just call it pack. Nope. Apparently I do not. Circle pack. Oh no, I'm sorry, it's D3 that called it pack, and I continue to call it circle pack. So same thing, except with circles. You'll notice it's suppressing that root node, right? Because it all follows the same logic. So we're hiding that top level node and so on. But actually, the reason I did this as a tree was because that's what I wanted. There's no difference between tree and cluster because of the way that this is formatted. This doesn't look so good vertically. Looks much better radially when you've got it with when you're hiding that root node, because radially it doesn't, it's not such a strong graphical assumption that that you build in there. You could also, oh, I'm sorry, that was the other one. There's also a partition layout, and partition layout also gets projected radially, which is great, but that isn't so surprising to people because a radial partition is just a sunburst, right? We'll stick with tree. So I've got this, that's what I wanted there. And there's one other thing that I wanted to do really quickly. I spent a little bit too much time doing this again. And that is that I wanted to build out a data visualization tooltip. So if you go and if you know anybody who played Pokemon, they all bought this book. And what's great is this book comes with this little radar plot of hit points, defense, special attack, special power, and attack. And I wanted to build that so that it showed up whenever I hovered over, where am I? Whenever I hovered over a Pokemon, right? And it's actually pretty easy. So if I go to my brushable scatter plot, I'll just build it here. Tooltip, here's my tooltip content, and it's doing all that stuff when I hover over it. It's giving you the name and the type and all of that. And if I just go and pull in an OR frame, then I can add an OR frame. I can tell that OR frame I want it to be the data is going to, now this is a little bit complicated because I've got to go take all of that data and I've got to go process it a little bit differently. So I'm trying to think about how I would do that. I'll write it as a little bit of a separate function. Keyed data of D. And we'll just do that up here real quickly. Function, keyed data. And I'm going to just return an array. And that array is going to have key and value. Key, attack, value. Let's go see what this, if I'm capitalizing anything, is anything capitalized? There we go. No, good. So, attack. And then I think it's DF for defense. So defense. And then, where are you, Pokemon? DF, SA, SP, and AT. Wait, so HP. It starts with hit points. HP, DF, special attack, special power. Is that what that SP stands for? That seems weird. I'm going to put special defense in there, whatever the heck that is. Or maybe that's speed. SP is speed, isn't it? Okay, so there's my keyed data that's coming back, because that's the form that I want data in for an OR frame. There's my data. I'll start with a bar chart, just so you can see. O label true, margin, and oh, axis. We want an axis, don't we? We always want an axis. Orient left. See how that looks. See if that works. Look at that. Look at that giant bar chart. Size. I don't know why I always forget my O accessor and my R accessor. I don't understand why I do that. So the O accessor is key in this case, and the R accessor is value. I want to give it a little bit of a style. Looks kind of orange to me. And some room between the bars and the bar chart. Because then the bars are right next to each other, they look terrible. So there we go. Now it's obviously not making the container very well. Tooltip content. Should size to fit, shouldn't it? I feel like it should. I'll take a look at that one too. Style equals width 300 px. But there we go. Now we've got a viz-in-tooltip, right? It's literally just the same thing. I mean, this is in your tooltip function. You can see the performance. It works, and it works quick, and yeah, and it works well. These are great devices to have in your data visualization. Obviously, I need more room on the left here if I'm going to go and deploy this. But for now, this does show me all of these values. Now, it doesn't show me those values as that little radar plot that evokes such nostalgia in people. So let's go to point. And now we've got these points. Now the points don't have a zero baseline. I think we do want a zero baseline, so we'll go with our extent. We don't want to define the top end. We want that to be defined by the data. So now we've got those points. Now we do that. We do a projection to radial. And there's my little points. And if I want to, I can say connector type equals true. And true will just literally connect the last value to the next value. I think I need to actually show them though. Connector style. Hey, come on, that's not fair. That's what it was supposed to do. Maybe I still have to send a function to connector type. There we go. I'll have to adjust that. Connector type should just take true. It's supposed to. So, and we can do a bit more with this because frankly I'm unhappy with the axis. I've always been unhappy with these axis ticks. Tick values 50, 100, 150, 200. It annoys me. It always annoys me. So, might be, maybe what I should do instead of that is find out what the maximum value is. No idea, because this is all based on weight and everything. And I am going to take the R extent. I'm going to set it up there because I feel like that's actually going to be a better story. You'll see the smaller ones smaller. Yeah, and then we get into the sort of weaker generations, presumably, and you can see that. Now this isn't quite a radar plot, and it makes me realize as I'm going through this that I should provide some functionality to do the fill and do the radar plot. One way around that is, I believe, if I do this as a bar, I believe it'll actually do what we want for a radar plot. No, it's going to do it as a pie. That's right. Yeah. So no. I'll go in here and I'll add that as a feature request to make sure that radar plots are doable so that people can have their proper Pokemon. But what I wanted to show is fundamentally what we've got here, which is a viz-in-tooltip that's taking the individual values and displaying them in this sort of radar plotty kind of way. We've got this hierarchical diagram here. It should be responding to the brush, and I'll make sure to go fix whatever bug cropped up with that, and along with all of those weird render key issues. But otherwise, pretty happy with it. So Thanks for joining me, as I like to say as often as I can. If you have questions, then feel free to reach out to me on Twitter or to post any issues you have on GitHub or otherwise contact me. I'm always happy to hear how people are using Semiotic, whether or not you have any feature requests, whether or not you found any bugs, or if there's some kind of use case where you think it might be suitable for, but it's not quite there yet. So thanks, and I'll see you next week.